All right, continuing with our central and inscribed angle rules, we're going to come across example 2 where we've got a little bit of an exception or kind of a special ruling. If we know that a central angle is going to be double in any inscribed angle, we can use that in certain, like this example here with the special case. So point C is the center of the circle, AB is 10, okay, and then BD is 6. So it's showing me all of that. What's the measure of angle ADB? If I want to know this angle, well, I kind of need to know something about this angle, and this is kind of where we get this exception. Technically, what this is, if I look at this is the arc, and it's creating an angle. Well, you might ask what angle that is. Well, if it's the diameter, it's actually a full 180 degrees, okay? Now, this angle here is actually subtended from the same arc. It's an inscribed angle because it's going to the side. This one's going to the middle, technically. Okay, so that means it has to be half. So that means it has to be 90 degrees. And we learned something about 90-degree angles back in 90-degree triangles back in grade 8. We know that there's a certain theorem, right, the Pythagorean theorem, that we can use to solve certain triangles. So if we know this is 90 degrees, then we have for ourselves a 90-degree angle or 90-degree triangle where this is 10 and this is 6. So what's the length of chord AD? The only reason I can do this is because it's a 90-degree angle. If it didn't work out like that, I couldn't solve for the Pythagorean theorem, but just refresh your memory, we can do c squared minus a squared equals b squared. So in other words, x is equal to the square root of 10 squared minus 6 squared. That's 100 minus 36, which is 64. Look at me go. So this is going to be 8. Okay. So that's kind of our exception or kind of our special case rule when it comes to central and inscribed angles. So look for that right angle triangle. So here's another situation here. Point C is the center of the circle. I'll just show you, you can easily just draw yourself a quick circle when you're doing this. Then we have an angle coming off here. And so we know this is 12 and this is 5. Okay, so take the time just to write that out quick. Doesn't have to be perfect. The measure of ADB, so on there, ADB, well this is again our 180 degree angle, which means if it's the central angle is 180, that means this angle has to be 90. Okay? And so then we could figure out the length of the diameter. So in this case, we've got a right angle triangle where we can just do a squared and b squared. Right? We do x equals the square root of 12 squared plus 5 squared. Okay, 144 plus 25, I believe 169, which means that the length of the diameter is actually 13. Okay, so that's pretty much all there is to this section. The last example just kind of gets you to recognize the central versus inscribed angle. So here, guy's working to take pictures of a house. He photographed with a 70-degree lens, so he basically covered just the house with a 70-degree lens. He comes back today, but he only has a 35-degree lens, so he obviously can't stand as close because then he's not going to get as much of the house. So the question is, where does he have to stand? And so kind of a silly question, but if we kind of imagine that this was the middle of the circle, and we thought of this, bad circle, but we thought of it something like this, then if we thought of this radius, he would have to go somewhere over here, right? So if he took the picture from over here, then he would be able to see the exact same. This would be a 35-degree angle, and he could take it from anywhere. He could take it from over here too, right? That would give you, because if I imagine it as this subtended arc, this would have to be half of that 70. So anywhere along the radius of that circle. So no one's going to be doing that kind of work, but there's your kind of situation where you're figuring that out. Okay, same idea here. A flashlight has a field of view measuring 25, and a camera has a field of view measuring 50. How can you position the camera and the flashlight? So again, if you wanted to take your 50 degrees, this might not be 50, but something like that. If you want to take a picture of something, there's your camera. Well, then your flashlight has to be somewhere. If if you imagine that it was a circle on a circle, then you know you can kind of do that calculation. Okay, but most of the questions are going to be more like examples 1 and 2, so you can work through that on page 382.